A person walks along a straight path at a speed of 1.2 meters per second. A searchlight is located on the ground 6 meters from the path and is kept focused on the walking person. At what rate is the searchlight angle rotating when the person is 10 meters from the point on the path closest to the searchlight? Okay, let's draw a picture so we can see what's going on. We've got this path. This person is walking along, and we'll let X be how far he's walked since this point here that is 6 feet away where the spotlight is. We know his speed is 1.2 meters per second, so that is the rate of change of x. dx dt is 1.2. Okay, we've got the searchlight, and so the light shines up to the man as if the man was here at x, and so this angle is going to be theta. And we want to find they give us a specific case, and that is to find the rate of change of the spotlight, so d theta dt, when the person is 10 meters from the point on the path closest to the spotlight. So this will be when x equals 10. So there's our specific, which we'll do in a minute. But now let's get our connection. Looking at the 6 and the x and the theta, I can see that's in a right triangle, and the connecting equation then would be tangent of theta equals opposite, which is x, over adjacent, which is 6. And we could solve this for x, so we'll multiply the 6 over, so we have 6 tangent theta equals x. So now we're going to take derivatives with respect to t of both sides. The left-hand side will become 6 secant squared theta, but theta is a function of t, so we have to multiply by the derivative d theta dt. And then x, the derivative is 1, but x is also a function of time, or t, so dx dt. This is our related rates equation. Since we are supposed to find d theta dt, let's solve this for d theta dt. So d theta dt will equal dx dt over 6 secant squared theta. Okay, let's see what we know. So if we can figure this out, we know dx dt, so we can put that in, 1.2 over 6. Now we need secant squared of theta, and we need it for our specific case, and our specific case is when the x is 10. So let's draw this triangle for the specifics. This is 6, this is 10, and so if I wanted secant, I would do, secant is the reciprocal cosine. Cosine's adjacent over hypotenuse. So the secant of theta would be hypotenuse over adjacent. Okay, well, I've got the adjacent side at 6, but I'm going to have to find the hypotenuse. So this will be a Pythagorean theorem. We've got 6 squared plus 10 squared equals the hypotenuse squared. So that's 136. So 136 is the hypotenuse squared. So the hypotenuse is the square root of 136. So the hypotenuse is square root of 136. Now that we have that, we can put in secant theta and square it. So the secant is hypotenuse over adjacent, so square root of 136 over 6, but that needs to be squared. So let's go ahead and simplify that. So the top is 1.2, and if I square the 136, that will get rid of the square root sign, and then this 6 squared would have been 36, but I'm going to cancel it with the 6 on top, so that'll just leave a 6. So it looks like what I have on the bottom is 136 over 6. Okay, let's go ahead and flip that over. So we've got 6 over 136. And then we'll put that in the calculator and we'll approximate to 3 decimal places. So 1.2 times 6 divided by 136, which is 0.053 to 3 decimal places radians per second.